Sorry. All right. So first of all, we're going to talk about order pairs can be stored. In a 2 by something matrix. Now it depends if you're storing a quadrilateral or we're storing like a triangle. Okay, if it's a triangle, it'll be a 2 by 3. Okay, because 3 points make a triangle, right? If it's a quadrilateral, gang, what would it be? A 2 by 4. Okay, so we're going to store a quadrilateral. We're going to call it matrix A. And the way the ordered pairs are set up is the X value in the ordered pair goes in the top row. The Y value of the ordered pair goes in the bottom row. Okay? And ask as we go, guys, if you have questions. Our quadrilateral has vertices A, B, C, and D. Point A is at -2, -3. Point B is at -1, 2. Point C is at 3, 4. Point D is at 1, -2. Okay, so we're going to go to our first graph, okay, and let's plot those. Letter A is translate. The quadrilateral, can I abbreviate that quad? Translate the quadrilateral. 4 units right. And 1 unit down. Okay, and this I need you to show matrix operations. Okay, so we're going to rewrite our matrix A. So just copy these down again. And this is going to be very easy, trust me. We want to add 4 to all the x's. So we're going to put 4, 4, 4, 4. And then Max said add -1 to all the y's. -1, -1, -1, -1. Okay? All right. And then we will get the matrix. I'm going to put it down here. And now you just do, all you do is add your elements. So -2 plus 4 is 2. -1 plus 4 is 3. 3 plus 4 is 7. 1 plus 4 is 5. -3 plus -1 is -4. 2 plus -1 is 1. 4 plus -1 is 3. And -2 plus -1 is -3. And you remember that those are called primes, A prime, B prime, C prime, and D prime. Okay? So now I'm going to go graph those, and I think we can put this one right on our same sheet of graph paper where we have the original figure. Okay? So you guys want to go plot A prime, B prime, C prime, and D prime. Can everybody see them all right? Now remember, if this is a rigid transformation, your image and your pre-image should be, what's that term from geometry? Square. Starts with a C. Yeah, they should be. Okay, so dilate the quadrilateral to half its perimeter. And maybe up here by translate, in parentheses, we want to put that we used addition. So, the question is, so translate was addition. Dilate. What operation do we think that is? Hannah? Good try, not quite. Okay. Brianna?
Multiply.
Yes. What kind of multiplication? It has a name. Scalar multiplication. So when we dilate, we do scalar multiplication. Okay. Then, gang, what's the scalar number? Pardon? A half or 0.5. All right, and then we want 0.5. And we want our original matrix. Always go back to the original, guys. Never go back to the new one. We always want to go back to the one at the top. We don't have to graph the original. So just graph on the second graph. We'll graph those. So does it look like the shape stayed the same, but it shrunk in size? So it should look like the shape stayed the same and it shrunk in size. Let matrix B equal -1, 0, 0, 1. Find BA. And what operation is in between there, but we don't see it? Multiplication. What effect does this have on the quadrilateral? So what effect does this have on the quad? Okay. Now, does order matter? If it says BA, what side does B have to go on, gang? The left side. Okay. So B has to go on the left side. So -1, 0, 0, 1 times, and then our original matrix, always back to the original, never a new one. Always go back to the original. So -2, -1, 3, 1. And then -3, 2, 4, -2. All right, shall we be fruitful and multiply? So, over 2, down 3, over 1, up 2, negative 3 up 4, and negative 1 down 2. Okay, everybody good? Now, they want to know, let me zoom out for a second. They want to know what happened between this one and this one. So what rigid transformation was it? Autumn? Over? Close? Yes, it's reflected over the y-axis. Can everybody see it's reflected over the y-axis? So, part of the answer is, let me zoom back in for you. Part of the answer is what effect, okay, and we're going to say reflected over x-axis. Y-axis. Now, what's the difference between the original matrix A and the new matrix A? What happened to the numbers? Go ahead, Autumn.
The x values is absolute x, or
The x values change sign, right? Okay, so when you reflect over the y-axis, the x's change sign. You know what made the x's change sign? Which number in here made the x's change sign? Yes. So when the negative 1 is on the top, that will make the x's change sign. Positive 1 on the bottom leaves the y's the same. What do you think a positive 1 on top does and a negative 1 on the bottom does? What would a negative 1 on the bottom do? Yeah, it would change the signs on the y's and it would be reflected over x. Yes, very good. Okay. All right. So how are you guys doing with the transformations?